Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 11. Develop rules for multiplying signed numbers. Alright, so example 1 says extending whole number multiplication to the integers, part A. Complete quadrant 1 and 4 of the table below to show how sets of matching integer cards will affect the player's score in the integer game. For example, 3 2s would increase a player's score by 0 plus 2 plus 2 plus 2, which equals 6 points. So our x-axis is going to be number of matching cards, and our y-axis is going to be integer card value. So for example, we'll have 3 matching cards, and those 3 cards are 2. That's what this example means, so it's 6. So we finish filling that in. So if I have 1 card, that's a 1, that's a total of 1. If I have 2 cards that are each 1, 1 plus 1 is 2, and so forth. So I'm going to finish filling in quadrants 1 and 4, and I'll be right back. Okay, so here's quadrant 1 and quadrant 4 completed, and part A says, what patterns do you see in the right half of the table? So if you look, this is 1, and if I go down here, it's negative 2, negative 2, 3, negative 3, 25, way down here, negative 25. So they are additive inverse, that's one way I could describe that. Okay, or their absolute values are equal. Now over here it says what quadrant does this quadrant represent? So this means number of matching cards. This means integer card value. So these over here means that we drew positive cards. Down here, since this is still positive, that means we are drawing cards. This means we drew a negative. Now B says enter the missing integers on the left side of the middle row and describe what they represent. So I'm going to put a negative 1 here, negative 2, negative 3, negative 4, and negative 5 there. Those are number of matching cards, and this is the integer value. So if this means drawing cards, then this must mean discarding cards. So I suppose that'd be the number of discarded cards. Part B says complete quadrant 2 of the table. So we do that. Okay, so here's quadrant 2. Now we need to answer the questions that go along with that. C. What relationships or patterns do you notice between the products of the values of quadrant 2 and the product values of quadrant 1? So we're comparing 2 with 1. So if I go back, quadrant 2 is here, quadrant 1 is here. So if you look, 1, negative 1, 2, negative 2, 15, all the way over here is negative 15. So it would also be the same as this here. So really what I could do is just take all that, back here, and put those answers down. Part D says, what relationships or patterns do you notice between the product's values in quadrant 2 and the product's values in quadrant 4? So now we're comparing quadrants 2, quadrants 4, back, Here's 2, here's 4. So if you look, -1, -1, -2, -2. Over 1 up 5 is -5. Over 1 down 5 is -5. So they're equal. So let's go back and write in what we prepared. Okay. Both quadrants 2 and 4 are all negative. Okay. And they are the same. What's in quadrant 1 is in quadrant 2 is equal to what's in quadrant 4 with their respective location. E. Here's what you know about the product's values in quadrants 1, 2, and 4 to describe what quadrant 3 will look like when its product values are entered. So if I go back and investigate quadrant 3, and I see positive here, negative here, and diagonally negative here, and this is the inverse of this, and this is an inverse of this. It looks like each quadrant next to each other are inverses, so this should be an inverse of this, or the additive inverse, I should say, or equivalent to quadrant 1. Okay, so E again says use what you know about the product of the values of quadrants 1, 2, and 4 to describe what 3 will look like when its products are all entered. So it will be the opposite of, so here I've done it. So quadrant 3 should be the same as quadrant 1, just reflected. It is the opposite of quadrant 4. It is the opposite of quadrant 2. So it's the additive inverse, or the absolute values are equal to quadrant 4 and 2. And they're all. So this answer would also go down here with respect to quadrants 2. Okay. Part C says to complete quadrant 3 on the table. So I've done that. There's quadrant 3 here. Refer to the completed table to help you answer the following questions. Is it possible to know the sign of a product of 2 integers just by knowing which quadrant each integer is located in? Yes. Quadrant 1, positive. Quadrant 2, negative. Quadrant 3, positive. Quadrant 4, negative. And it says explain. Well, it's because, and I'm going to explain it speaking, not writing. It's because first quadrant's positive, because a positive times a positive is positive. Quadrant 2 is negative, because a negative times a positive is negative. Quadrant 3 is positive, because a negative times a negative is positive. Finally, quadrant 4 is negative, because a positive times a negative is negative. Which quadrant contained which values? Describe the integer game scenario represented in each quadrant. So quadrant 1, I've already explained the values. They're up here, positive, negative, positive. Quadrant 1 means to draw positive cards. Q2 means to, let's take a look, quadrant 2, number of cards and what they are. Okay, here's our Y column, integer card value. So a -1 means to discard this card value. So if I discard a negative, or if I discard a positive, this means to discard. So if we're going to discard a negative, our value increases, or positive. If we're going to discard a positive number, the value will decrease. Okay, quadrant 3. We go back and look at quadrant 3. we're discarding negatives, so our value in our hand will go up. Okay, so we're discarding negative cards. And then finally, quadrant 4 means to withdraw a negative card. Let's take a look at that. So quadrant 2, this means to draw how many? Number of matching cards. That means to draw, and that means the card value. So drawing 2 negative 2s will decrease my value by 4. Okay, so example 2 says using properties of arithmetic to explain multiplication of negative numbers. So thinking about the integer game with cards. If we add a number multiple times, it's the same as removing the opposite. Think about that. So if I have an ace in my hand, and I have 3 of them, that's worth a total of 3 points. But if I remove them, that reduces my hand value by 3, which would be the same as drawing negative numbers to equal negatives. So what they're saying is -1 times a -1. Removing a negative card is the same as adding a positive card, so -1 times -1 equals 1. Okay, the next thing we want to look at is why are 1 and -1 called additive inverses? Write an equation that shows this property. So we can say the sum of 1 and -1 is 0, or 1 plus a -1 equals 0. So we call them additive inverses because whenever we add 2 things together and get the additive identity, which is 0, then they have to be inverses. So adding an inverse equals the identity. A lot of terminology here, but we need to learn it. Okay, so now we're going to show that -1 times a -1 equals 1 using properties of arithmetic. So we know that 1 plus a -1 equals 0. That is true. We're going to show that -1 times a -1 is the additive inverse of -1, which is 1. All right, so try to follow along. If -1 times 0 equals 0, that's the zero product problem. Anything times 0 is 0. So if, I'm going to color code, this value here, -1 times 0 equals 0, then -1 times 1 plus -1 equals 0. Because up here, we know 1 plus -1 equals 0. So I'm going to substitute in this 1 plus -1 in place of this 0 here. Since 0 equals 1 plus -1, I can put this wherever there's a 0. So now I have this -1 here times, instead of 0, 1 plus -1, which is my green here. Because it's equal to 0. Substituting in 1 plus -1 for the 0 value. Okay. Next, we're going to take -1 times 1 plus -1 times -1 equals 0. So what happened here was we're taking -1 times 1, and that's right here, and then we're taking -1 times a -1, which is right here. That's called the distributive property. We are distributing the outside number to each term inside. That's called the distributive property. So then once we do that, we now say -1 times 1 is -1, and that came from here. Let's do this. Okay, -1 times -1 is the additive inverse. So -1 plus -1 times -1, which is right here. that equals 1. Okay, so this is equal to 1 right here. It says it right here. -1 times -1 equals 1. So -1 times -1 is 1. So -1 plus 1 equals 0. Multiplying by 0. So what did we just prove through all this mess? Did you follow? Do you understand what just happened? It's a lot of substitution. It's a little confusing. I will explain it again in class. But all we're doing is plugging values in when we are given from our properties. Okay, so now I brought in the next step, and it says since -1 and -1 times a -1 have a sum of 0, okay, this plus this equals 0, then they're additive inverses each other. But the additive inverse of -1 is 1. So therefore, what's underlined in black must be equal to 1. Okay, and finally the last step, because -1 times a -1 is the additive inverse of -1. Okay, that's the additive inverse of -1 because it equals 0. We can conclude that -1 times a -1 equals 1. This fact can be used to show that -1 times a being any number equals the negative of that number for any integer. And that -a times b is equal to the quantity a times b for integers a and b. So this is just an intro now into algebra and how we're going to start using the properties of algebra to solve equations. Okay, so exercise 1 says to generate a real-world situation that can be modeled by each of the following multiplication problems. Use the integer game as a resource. So here I could just say I lost 3, that's negative. I lost 3 $5 bills. Now I have -$15 or $15 less than what I had before. Okay, there's example 1. -6 times a -3. Okay, so let's play the integer game on this. Okay, so I can say I removed 6, removal means negative. I removed 6 -3 cards from my hand. My hand value increased by 18 points. Okay? So a negative times a negative is positive. Finally, 4 times -7. Okay, let's talk about weight loss. If I lose 7 pounds per month, okay, there's my months, for 4 months, comma, then I lost a total of 28 pounds. Okay. to be negative. My weight changed from negative to okay, I believe that's it. Yes, so that's the end of the lesson. Go do your problem set.